Welcome to our lesson 6. Okay, our lesson 6, and this time we are going to concentrate on power. We are still doing work, energy, power, and machines. Okay, so let us focus on the board and try to see how do we define power. Okay, let us focus there. I think we are done there. So power is the rate of doing work. Power is the rate of doing work. In other words, it is the rate of energy change. You know why? We said when there is energy change, work is done. And for that reason, work and energy share the SI unit, the joule. So when I say power is the rate of doing work, then I'm justified to say it is the rate of energy change. Okay? So mathematically, we write power is equal to work over time, giving us SI unit, joule per second. The joule per second is also known as watt, symbolized capital W. Okay? Every time you have these quantities, it's good to know their SI unit. But this work, we have been explaining it from force times distance point of view. So if I substitute W with F times D, and D I align it over T for it to give you a picture of velocity or speed, then you get power is force by velocity. This is the approach you will have in conveyor belts, that these belts move at this particular speed. Okay, so here you have kind of three aspects. You have the basic power is work over time. In bracket, power, energy change over time. Okay? Then you have power is equal to force times distance over time, which gives you the distance over time becomes that. Okay? It is a simple one. So let us look at a few examples because it is as short as that. Remember, we started with the energy, we came to work, now we are doing power. Energy is the rate of doing work. Energy is the ability to do work. Energy is the ability to do work. Then since we have the word work, we defined work as force applied on a body and that body moves in the direction of force. Work is force times distance. That distance cannot be perpendicular to the direction of force. It cannot be oblique. It cannot be at an angle. Not that those ones are not possible. They are possible, but they are not studied at this level. Okay, like a lawnmower. Do you know a lawnmower? You are applying force at an angle. The lawnmower cuts grass on the level ground. So you see, force applied is at an angle to the level ground. We are not dealing with that. Okay? So you have energy is ability to do work. We had energy changes. Then work is force times distance. Work is done when force applied on a body makes it move in the direction of force. Then there we had a note. Moments is force times distance. But the distance in moments acts perpendicularly to the line of action from the pivot. So here we want to see this man, this man, focus a bit there. Yes, this man has a weight of 480 Newton and climbs stairs up to a height of 10 meters. Okay, and that happens in 12 seconds. In 12 seconds, a person, okay, find the leg muscle power of one leg. We are assuming those legs are functioning the same, but the bottom line, how many legs does a person have? 2. So we sort this, that F is equal to 480 newtons given in terms of weight. I don't know, I want to focus the camera a bit down. We focus it down so that we continue. I don't know if there it will work. Yes, there is enough working space. We have there W. Can I do it in red to make my work colorful a bit? We have weight given, which is a force, and it is 480 Newton. Then what else are we given? We are given distance. So I write distance. In most cases, please write distance in full. Distance. Okay? Yeah. Because from linear motion, distance takes another form, another letter, S. So distance is equal to 10 meters, and then we have time is equal to 12 seconds. Very important. Our time here must be in seconds. Okay? Yeah. So F in Newton, distance in meters, time in seconds. Here, force in newtons, velocity in meters per second. So you work with SI. Okay? Now, this is the scenario we have. So we go and calculate first what is the power that man develops. Power. Okay? I will use power is equal to, now, force times distance over time. Substitute 480 times 10 over 12. So I can write just over 12. It doesn't matter. This gives me 4, which is 400 watt. Then I finish my question that one leg muscle power is equal to 200 Newton. Do you know why there, folks? Do you know why there? Why have I moved from 400 to 200? Can somebody answer? Yes, you should be able to know. 400 watts is the power the 2 legs developed, because you are told a person. And then the question is narrowing to a leg. So you ask yourself, how many legs does a person have? A person has 2 legs. So if I'm asked for 1 leg, I divide by 2. Okay? Right. I want us to try and get another question. Maybe I can get another question. Meanwhile, check the work there. Check the work there. I get the second question. If we get 2 questions to be better, and then we okay, a person weighing, we are getting another question. I don't know if I can rub so that I share on the board. I think the best thing is to rub. Okay, yeah. So a person weighing 500 newtons, a person weighing 500 newtons takes 4 seconds to climb upstairs to a height of 3 meters. A person weighing, so we do weight is equal to 500 newton, okay, takes 4 seconds, time is 4 seconds, and then distance is equal to 3 meters. So we are given a height, which is the distance is 3 meters. Okay, what is the average power in climbing up to that height? What is the average power? So I write P is equal to question mark. Okay, now I come and do my work. I say power. This is sorting out. If you are forgetting, sorting out is to write a letter. Okay, we were given weight, and this weight we know it is a force. Okay, weight is a force. Weight is a type of force. Okay, so after sorting the letter and the figure, you keep on checking the units. Okay, and then the question is this. So this, in short, this should give you a formula. It should give you a formula directly or a modified formula. So I write my knowledge now. Step 2, write your knowledge. Power is equal to dW over T. Okay, and this is the same as force times distance over time. That is the knowledge I'll use for sure, because I'm asked about power. So I look at what do I have. Do I have F? Yes. Do I have D? Yes. Do I have time? Yes. Are they in correct units? Yes. Substitute. Maybe I put it here so it is nice. F is 500. Distance 3 meters. Time 4 seconds. So what answer do you get, folks, there? 375 watts. So sometimes we would mark it this way. 1, 1, 1. Okay. So you can see, you can focus if you are not seeing well there. You can see these are called free marks because they depend on this knowledge. The sorting out is to help you come up with a formula. Then you substitute using, you remove letters, you put the figures that have already been converted. If you are to do conversion, do it separately so that you don't mix many steps. Mixing many steps is what will make you lose mark. So I suggest do conversion separately so that when you have a formula of 3 quantities, like I want to get power, I'm told you must know force, distance, and time. So these are 3 figures. 1, 2, 3. 1, 2, 3. Okay? Your work becomes so simple. Okay? If I write W is equal to mg, meaning that for me to get W, I must know m and I must know g. Don't start converting m there. That you have been given 200 grams, you divide by 1,000. No, just do it somewhere so that when your formula W requires mass and gravity, your substitution should have 2 figures. for mass, for gravity. Life becomes simple because you are segmenting your work. But the problem with the students, sometimes you want to do conversion in that formula, you mix yourself and you lose marks. Exam is about marks. There are no two ways. You either have the mark or you don't. Folks, keep on subscribing. You will get everything from this channel. Tell your friends. Don't just say we know it. No. Talk to a friend. Maybe we have only Form 4 back in school. Form 1s are still at home. Form 2 at home. Form 3 at home. Don't be there. Tell your friend in the church. Can you try to Google this? Learning with Odecho. Bye bye. See you lesson 7.